Hello, this is Nat McCulley. This is my final project for Math 6610 Fall 2014. My dataset that I chose for this particular project uses the dataset website. It has a number of variables, identification number, we didn't use that. Websites delivered, we used. Backlog of orders, we didn't use. Team number, team experience, process change, we didn't use that. We do use years to some extent, but not all the way through, and we're definitely using quarter. So quarter, team number, and websites delivered. Just a quick little narrative I came up with to make this a little bit more fun and more real for me. Our project uses the quantitative variable websites delivered. It also used the categorical variables team number and quarter. And like I said, I was making up a little bit of a narrative here. Basically, the way I looked at this data set was it's a company that develops websites and it wants to do a study to see if all of our teams are developing websites at about the same pace, or possibly to see if one team is doing better than the other or if teams are lacking behind. And we did this study over our first year, which was the first 4 quarters of 2001. When I went through the data after I came up with this narrative, I noticed that the company was adding new teams throughout 2001 and 2002. So if a team was added after the first quarter of 2001, it was removed. So we're comparing apples to apples. And then to facilitate proper recognition of variables in R, team numbers, which were given as 1 through 7 for this particular data set, were changed to letters A through G, and quarter numbers 1 through 4 for 2001 were changed to Q1, Q2, Q3, and Q4. The reason I did this is because as I watched some of the videos, there were often problems with numerical values in categorical variables and having to go through and change things to factor. So I figured if I changed it so that it would be a factor, that the quantitative variable website being numerical and the categorical variables team number and quarter would be easily read by R. This is my data set. You can see here are my teams A through G. This score represents the number of websites that it completed during the quarter 1, quarter 2, quarter 3, and quarter 4. So my statistical measure to compare this rate at which teams are completing websites, I ran a repeated measures ANOVA, and my null and alternative hypothesis, mu sub A equal to mu sub B equal to mu sub C, all the way up through mu sub G, where mu sub I is a group mean for the given team, were all equal. The alternative hypothesis, at least one pair of group means being different. And so I did a little bit of searching through the descriptive statistics, the mean values for all 7 groups over the 4 repeated measures, and I saw that my highest mean at 6.75 and my lowest mean at 3.0 was fairly large. But that didn't concern me nearly as much as the fact that my largest standard deviation at 4.5 was twice as much as my lowest standard deviation. That gave me some concern about the assumption for homogeneity of variance, and that was covered during the class. And so to address this concern, I used Levene's test for the homogeneity of variance, and it returns an F statistic with degrees of freedom 621, and that F statistic was 0.6321. Its p-value was 0.701. So in this particular instance, there is evidence that supports the assumption of equal variance for this data set. Looking at some of the plots here, I looked at this histogram, and this had me very worried when I first threw up the histogram. thinking that I might have a little bit of a problem with my my subjects coming from a non-normal curve. Also, looking at this set of box plots, I have a couple of means, namely D and E, that were significantly different than some of the other teams' median values. So these median values were a little off. Again, just kind of reviewing what we saw on that histogram, on the pictures. Was worried about normality in both the histogram and the box plots, my assumption of normality. To address this concern, I ran the Shapiro-Wilks normality test, got a number of p-values, none of which are statistically significant at the 0.05 level. And so since none of those tests returned statistical significance at the 0.05 level, there is certainly some evidence for supporting the assumption of normality. Finally, the assumption for sphericity was addressed through Malchley's test for sphericity. I used the EasyANOVA command in R, which returned a W value of 0.387 with a p-value of 0.459. Again, these results lend statistical evidence in favor of the assumption of sphericity. Can't be sure, but at least we have a little bit of evidence. So my inference here, I ran a repeated measures ANOVA design to compare the average number of completed websites for teams A through G over the first 4 quarters of 2001. My F statistic had degrees of freedom 3, 8, and it came up to be 3.019 and with a p-value of 0.0568. Indicating that at the 0.05 significance level, the null hypothesis, stating that there are equal means between teams A through G, should be failed to be rejected. The effect size using the eta squared method was 0.335, indicating a very large effect. Using G-power, G-power needed Cohen's F to calculate, so I did that from one of our given equations, and it came out to give me an F of 0.701. It was used in G-power, which calculated an achieved power of 0.999, which is pretty darn large. Since I did get such a small p-value, even though it wasn't statistically significant at the 0.05 level, I was a little worried at first, and so I did run a pairwise t-test, and when I got these results, I almost didn't include it, but just to kind of show, it kind of seems to make sense, as type 1 error would probably be propagated over the repeated measures ANOVA. In summary, the statistical analysis did not reveal any significant differences between the 7 teams of website developers. In this case, not finding a significant difference between teams can be just as important as finding one. If you're a company and you're trying to make sure that your teams who are completing websites are doing it at about the same pace, it's very important to know that all of your teams are doing approximately the same. None of our teams here in this data set were doing exceedingly well, but also none of them were lagging far behind. So if we assume that the average pace of each team is efficiently completing projects and producing profitable results, we can look upon the results of this analysis as a positive result. That is the end of my presentation. I want to thank you for allowing me to present in this manner. I appreciate it. And I hope that I have met all the requirements of the project. Thanks again. Have a good one.